All right, I think I will get started with introducing myself. So, my name is Valencia. I'm one of the tutors at Burwood Alpha One's Burwood branch. And yeah, I teach a little bit of the selective trial test classes and a little bit of our, writing, English, math, thinking skill courses. Today, we'll be going through a mathematical reasoning challenge for April. And without further ado, I might get started. So, with question one, it says Melissa needs to weigh out exactly 450 grams of flour for cake. She takes out an empty bowl and places it on the scale as shown below. She then scoops out 4 small cups of flour into the bowl, and the weight changes are as shown below. So, if we look at this very first graph or picture here, we can tell that the bowl, while it's empty, is weighing between zero point 0.6 and zero point 0.8 of a kilogram. And the number that we're looking at is 0.7 kilograms there. Now, I want you to kind of ignore what this looks like, but after she scoops out 4 small cups of flour into the bowl, we have both the bowl and 4 cups of flour in there for this scale here. And we can see that it's now at 0.9 kilograms. Hopefully that makes sense. And what we can tell here is we can substitute the 0.7 kilograms into this second equation because we know that the bowl weighs that much. So we know that 0.7 kilograms with 4 cups of flour inside is going to weigh 0.9 kilograms all together. Hopefully you understand that that means 4 cups is going to equal to 0.2 kilograms. So that's me subtracting 0.7 off from both sides of the equation. And that means that 1 cup of flour is, 0.2 kilograms, or you can think about it as 200 grams. If 4 cups is 200 grams, 1 cup would be, we divide both sides here by 4, and 1 cup would be 50 grams. Okay, now if you look at what the question is looking for, it says, how many more small cups of flour does she need to add to the bowl? If we remember, the question said she needed 450 grams, right? So 450 grams would be how many cups if 1 cup was 50 grams? We would need to multiply both sides of the equation here by 9. We need 9 cups of flour to reach 450 grams. And remember, we've already put in 4 cups of flour, meaning that we only need 5 more cups. Okay, so that's why the answer to question one is C. Hopefully that one makes sense. So a recap of this one, really, you just needed to make sure you substitute it from working out how much the bowl weighed into this equation here. And then you need to solve for how much a cup weighs. Know that we need 450 grams, which is 9 cups, and we just need 5 more since we've already put 4 in. Okay. Now, question two. So, Farmer Joe was packing oranges into cardboard boxes to ship them to distributors. Each box can hold 25 oranges each, and this season's harvest yielded enough oranges to fill 18 boxes completely and have 7 oranges left over. So, how many oranges were there in this harvest season? Hopefully, this one is pretty straightforward to you guys as well. So, we know that one box is going to be 25 oranges, and we have enough to fill 18 boxes completely. So let's have a think about how to do that. So if one box is 25, then 18 boxes would be 25 times by 18. Now, there are 2 ways to do this. The first way is you can do your whole algorithm multiplication, but in my opinion, it usually takes a little bit longer. How you guys can think about this is, yes, you can do your algorithms, which if you're comfortable with, go ahead. But the other way you can think about it is 25 times 20, we know is 500. And that's just 2 lots of 25 less than 25 times 18, right? And we know that 2 times 25 is 50. So all we need to do is subtract 50 off the 500, and we end up with 450. Now, remember, that's not our final answer because that is just what fills 18 boxes. Remember, we have 7 oranges that are remaining as well. So we need to make sure we add that on to the end. That's why the answer there is E. So what I'm showing you here is just a slightly faster way of thinking about your maths so you can do it mentally rather than having to write everything out. Okay. Question three. So the following diagram follows these rules. So all the numbers have to be positive whole numbers. So we're looking at anything that doesn't have a fraction or a decimal. None of the numbers can be the same as each other. And the circle in the middle is the product of all the numbers in the squares. So product means when we multiply all the numbers. Essentially what it's saying is 6 times 5 times 4 times by the unknown number has to give us what's going to be in the circle. So it says which of the following could be the missing number in the circle, right? So let's go through each option at a time. The first option is 120. If we look here, our current product is already 120, isn't it? So for A, what would we need in that square if we were to get a product of 120? We would need to multiply 120 by 1, right? And that satisfies our conditions, doesn't it? It's a positive whole number. It is not identical to any of the numbers inside the square. So the answer for question 3 was actually A. But let me show you why B, C, D, and E also don't work. Okay, so B, how do we get to 480 from 120? We need to multiply that by 4. But the issue with the number 4 is, can you guys see it's already been repeated? It's a repeated number, so B is not possible. Now, if you guys have a look at C as well, we have the same issue. To get to 600, we need to do 120 times 5. And again, it's repeated. We've got a 5 up here. This one's repeated. D is a little bit different because we know that 120 is not a factor of 660. We actually need to multiply it by 5.5 to get there. And it doesn't satisfy our condition that it needs to be a positive whole number. Okay, so that's why it's not C and not D. And for the similar reason why it's not E, to get to 720, we need to multiply 120 by 6. But as you guys know, 6 is also repeated. So the only option here that works without repeating any of our numbers and to have positive whole numbers, we need to do times by 1, which is A. Hopefully that one makes sense. So, question 4. Rachel, Peter, and Sonia are sharing 2 bottles of juice between them. Both bottles have the same volume of juice. Rachel drinks half of the apple juice, Peter drinks 3/8 of the orange juice, and then we have Sonia drinking a quarter. So let's have a look at each one, and we're trying to prove which one of these statements is right. So together they finished the orange juice. Now we have to check that, right? So let's have a look at the apple juice first. The apple juice, we know Rachel drank a half of the bottle, and we know that Sonia drank a quarter. Now, a half plus a quarter, as we know, is 3/4. So is statement 1 correct? Well, that one's looking at apple juice. We don't know yet. Orange would be 3/8 plus 1/4. And as you guys know, we can't add things with different denominators. So let's make everything over 8 first. How do we get to 8? We need to multiply both the numerator and denominator by 2. And from that, we get 5/8. That means only 5/8 of the orange juice is finished. So did they finish the orange juice? No, right? Did Sonia drink the most amount of juice? So if both bottles have the exact same content in them, if Sonia drinks a quarter from each one, altogether, Sonia's actually drinking a half of all the juice. Did she drink the most? No, because remember, Rachel also drank a half of the apple juice, and that is going to be the same volume. So statement number 2 is also wrong. And number 3 says there is more orange juice left than apple juice. So if you guys look at how much is left, if we drank 3/4, we know that there's 1/4 left. If we drank 5/8, we know there's 3/8 left. Okay. Is there more orange than apple? So we know that 1/4 is the same thing as saying 2/8, right? There is more orange. There's 1/8 more orange juice than there is apple juice. So statement 3 is correct. And so that means our answer is B, only statement 3. Okay. Hopefully that one makes sense. Just a little bit of fraction work. Okay. Question five, I would regard as one of the easier questions. So it's asking for the number of days in 2 decades, right? So we're looking for something, a calculation that can show us that there are how many days there will be in 2 decades. So a decade is 10 years, meaning if we have 2 decades, that would be 20 years altogether. And as you guys probably know, one year has roughly 365 days. And I know there are some days where you can say, oh, there's 366 days. But for the sake of this question, I would just assume it more simply and just show, as you can see, in none of these options, they say anything about, leap years. So just keep it simple and recognize that there's 365 days per year. And we're basically done because we already see an option for that. Okay. Okay. Question number six. A radio station has created a chart to display the contents of their total airtime in a 24-hour day. So I think there's something really interesting about pie charts that we should always look for, which is anything that has right angles or anything that is showing basically half of the pie chart. Now, the question is asking, what is the total time that spent on music, right? And we're told that news is 4 hours long. If you guys have a look at this, it's really quite interesting because if you guys see, we have one right angle here, but this one doesn't really matter to us. What really matters to us is the fact that news and music all together give us exactly half the circle. And if we know this whole circle represents 24 hours, then we know that half the circle will represent 12 hours. So that's really interesting because now we know that news and music together should give us 12 hours. And we actually already know that the news is 4 hours. So that must mean that music lasts for 8 hours. So whenever you're coming up with pie chart questions, I would always have a look at, especially when they want you to find out what one portion of the pie chart represents, look at things like right angles, look for things like straight angles as well. So straight angle case, we can just assume straight away that it's going to be half the time, which is 12. Okay, hopefully that one makes sense. Question seven. Now, this one is a little bit harder, but with any scales question, I would always recommend to eliminate what is common on both sides first. So let's have a look at this one. It says the total mass of objects on the left-hand side must be the same as the total mass of the objects on the right. We know that. Every cylinder, every cube, and every cone has equal mass to its opposite side. So cone weighs the same as another cone, right? And if you guys have a look at these two scales, you should immediately see that there is one cone on either side of this scale that we can actually rule out. And why we can do that, if you think about it, is if you take away two of the same weights from each side of the scale will still be balanced. So if we have a look at this, let's write this out into words to make this a little bit easier for us. We know that there's one cylinder on the left-hand side. So I'm looking at this one first and one cube on the left-hand side. And collectively together, they give me one cone. And we know actually that one cone weighs 0.7 kilograms. Let's keep that one in mind. And if you have a look at the second scale, there's nothing we can actually eliminate from both sides. So let's just write it down. We know that 2 cylinders is the same as 3 cubes. Now, what's interesting here is, can you guys see that on the left-hand side of equation one, we're expressing things in terms of either cylinders or cubes. So this can really go either way. It's really up to you guys. But what we can do is we can say if 2 cylinders are 3 cubes, then one cylinder would be 1.5 cubes by dividing both sides by 2. And that means now we can actually substitute this part here back into equation one. Why I'm doing that is whenever we have an equation where there are two things we don't know, it's really hard to solve. But if we only have one thing we don't know, things are a little bit easier. So if you guys have a look here, that means that the equation one becomes 1.5 cubes because I'm substituting the cylinders plus 1 cube equals to 1 cone, right? And we know that one cone is 0.75 kilograms. So let's write that in. So now this means that 2.5 cubes equals to 750 grams, right? or you can keep this as kilograms if you like to work with decimals. And if 2.5 cubes is 750, we can divide both sides by 2.5. So 1 cube would equal to 750 grams divided by 2.5. And hopefully you guys understand that that is 300. Okay, so that gives us our answer of A. Okay, hopefully that makes sense. So yeah, what we do here is first step is with a scale, eliminate what's common on both sides. And then I like to write things out. You might not like to do that, but I just like to have things clearly written in terms of what I know. And so I can work out what I need to find out. Okay, question 8. So Mitchell owns numerous pet frogs. In order to update the feeding chart, he weighs each of the frogs weekly. The following chart shows the current weight of the frogs as well as their weights 1 week ago. Which frog gained the most weight over the last week? So for this question, we're looking for what is which frog has the largest difference between their last weight and their current weight. So let's have a look at which, kind of sillier option we can eliminate first. If you guys have a look at each option, you'll probably notice that Bridget is definitely not going to be our answer because Bridget has a weight difference of less than 2, right? Less than 2 grams. She only goes up by about, 1.19. Okay, so we know it's not going to be Bridget. But if we have a look at the others, Alan gains about 2.65 grams. Cloudy is easy. Cloudy gains 2.6 grams. So from that, we already know it's not going to be Cloudy either because Alan had a bigger weight gain. And then if you guys look at Dart, Dart gained what? 3.21. So we also know from here we can eliminate Alan, right? Because Dart had a bigger weight gain. And the last one we should check is Eggy. So if you do 12.22 minus 9.1, you should get 3.12. And so we know that it's not going to be Eggy either. Dart has the biggest weight gain here. Okay. So how I would approach these sorts of questions is always eliminate your silly answer first, the one that just obviously isn't right. So you don't do extra work for yourself. Okay, cool. Question 9. So, question 9 is a very classic directions question. An archer is standing in a tower T facing the sunrise east. She turns clockwise until she's facing her village at V. What was the angle of her turn? So, if I could write down what's going on at the moment, can you guys see that north is actually facing what we would normally draw as the south option, right? So, how you guys need to draw what direction this archer is originally facing. We're not going to draw east here because remember, this is like the northeast southwest, but it's been rotated 180 degrees, right? Meaning that east is not to the right, but it's to the left here. Okay, so just be careful of where what direction they're showing you. They would like to trick you sometimes. Okay, so it says she's facing east and she turns clockwise until she's facing her village. Be very clear that you know which way is clockwise and which way is anti-clockwise, because the answers, as you guys can see here, are out to trick you. So clockwise is going to be this way. She's going to turn this way until she reaches her village, right? So let's draw that out. We know that from where she's facing at the moment to east, for her to get to west, she needs to turn 180 degrees. Then from west to north, she needs to turn another 90 degrees here. And then she needs to turn another 50. So altogether, to face her village, she needs 180 degrees to turn all the way to west. Then she needs to turn another 90 degrees to face north. And her village is 50 degrees in the northeasterly direction. So we need to add that on to the end as well. This would be 180 plus 90 is 270. 270 plus 50 is 320 degrees. So your answer is E for this question. Okay, if I can offer any advice, just please make sure you know clockwise, anti-clockwise, don't make the silly mistake, and also just know what direction they're giving it to you. In this case, they were trying to trick you with the north there. Okay, Question 10. So Abigail is running a fast food shop and has 2 sacks of 20-kilo potato chips at the start of the week. On Monday, she used a quarter of the sack. On Tuesday, she used 8 kilograms. Wednesday, she used a third of the remaining. Whenever they say remaining, it means we actually do need to calculate that amount. And on Thursday and Friday, she used the same amount of chips. If there is half a sack of chips left at the end of Friday, how many chips did she use on Thursday? So let's work down from each day. If she has two 20 kilos of potato chips, that means she's starting on 40 kilos altogether. And if she's using a quarter of the sack on Monday, that means she's using a quarter of, not, she's not using 40 kilos. Remember, it's a quarter of a sack, right? And one sack only had 20 kilos in it. So she's actually only using 5 kilos. Okay. Try not to do a quarter times 40. On Tuesday, she uses 8 kilos. So altogether, she's used 13 kilos so far. And that means by Wednesday, how many kilos does she have left? So if she's used 13 altogether, there was 40 in total. The remaining amount would be 40 minus 13, which is 27 kilos. And why that's important is, remember, Wednesday, we want to calculate, how much is left after she uses 1/3 of the remaining chips. So a third of the remaining, which is 27 kilos, would be she uses 9 kilos on the Wednesday. If she uses 9 kilos on the Wednesday, we know by Thursday and Friday, she will have 27 minus 9 kilos left, which is 18 kilos. Okay. Are we okay with that? Hopefully. Okay. And then if there is half a sack of chips left at the end of Friday, how many chips does she use on Thursday? So remember, one sack of chips was 10 kilos. So if she used half a sack, right, of the chips, and that means that there's going to be 10 kilos remaining by Friday. She uses 10 kilos. Sorry, if there's half a sack left, that means there's 10 kilos left at the end of Friday. So how many chips did she use on the Thursday? Well, on Wednesday, remember, we had 18 kilos left at the end of the day, and we have 10 kilos left on the end of Friday. So how much would she have used on Thursday? It must be that remaining amount, which is 8 kilos. Hopefully that one makes sense. It's just a lot of like working in a sequence, and just sorry, my bad. Sorry. There's one thing that I haven't done. It says she used the same amount of chips on both days, right? So that means that there was 10 kilos remaining, so she used 8 kilos over Thursday and Friday. Sorry if I confused you there. So that means it's 8 kilos over Thursday and Friday, meaning it's actually 4 kilos per day. Okay. Let me clarify quickly what I've just done there. So at the end of Wednesday, she had 18 kilos left. And then at the end of Friday, there was 10 kilos left. That means we used 8 kilos over the Thursday and the Friday. And we know we used the same amount, meaning that we must have used 4 kilos per day. Okay, hopefully that makes sense. All right, question 11. So Liesel is playing with 1 centimeter small cubes. Each cube is identical and looks like this from the side. Liesel constructs a rectangular prism using 240 cubes. Below is the view of one of the faces of the rectangular prism. So if this is one of the faces, right, can we see that there's 30 cubes being used for this face? It's a 10 by 3, right? And that means that if we have 240 cubes altogether, it must have been something that is 8 cubes thick, or the width of it is 8 cubes. Okay, so that's how we can get to 240, right? If this layer is 8 layers thick. So if we have a think about it, that means this is a 10 by 3 by 8 shape. So to work out the surface area, we kind of just have to go, step by step by step. So the first step I would say is break it down and just do the front and the back first. So we know the front is what? 30s, 30 squared centimeters, right? And the back is also going to be 30 squared centimeters. If we do the side, we know that it's going to be 3 by 8. And that will be, there's 2 sides, so we need to add that twice. And then if we do the top and the bottom, we know it's going to be 10 by 8, right? and there's going to be two of those. So we get 160 squared centimeters. Okay, so when you're doing surface area, just be really careful that you're doing it step by step. So 160 plus 60 is 220. And then 220 plus 48 is just 268 squared centimeters. So the answer is D. Okay. And question 12. So Miss Jackson has been recording the attendance of her class for over a week. She wants to make a picture graph to show the data in the following table. She only wants to represent people as like either whole students or half students, meaning that if the whole students represented 4 students, then half students as a picture would represent 2. So she won't draw any other fractions. So she's not going to draw a quarter of a student or 3/4, for example. Okay. Which of these keys can she use to represent the data accurately? Now, this is kind of a question where you need to filter out some irrelevant information. So if you guys have a look at the 3 different keys that she presents, 4, 6, and 12, well, it's a little bit interesting because if you notice Monday, Tuesday, and Wednesday, can you guys see on Monday and Tuesday, right? For example, Monday, 4, 6, and 12 are all factors of 24. So if we use 24 as the way to kind of measure how many students she's using as a key, it doesn't actually help us because we know that it's going to be, 6 and 4 and 2, for example, right? And 18 as well, 6 is one of its factors. One of the more interesting ones that I would pick to check is 27 because 27 is not an actual multiple of any of those numbers there. And because of that, it will make us, it'll give us a fraction or a remainder where we'll be interested to know whether these keys actually work. So let's check 27. If the key represented 4 students, if we do 27 divided by 4, that would be 6 full students, right? We would have 6 of these diagrams, and it's remainder 3, isn't it? Or 6 3/4. Can we actually represent 3/4 in a diagram? We can't. We can only represent half students, right? So key 1 doesn't actually work. And key 2 says it represents 6 students. 27 divided by 6 is 4, remainder. So 27 divided by 6 is what? 4, remainder 3, or 4 and a half. Can we represent half? We actually can. So this one works. And key 3 says represents 12 students. So 27 divided by 12 would be 2, remainder 3, which is 2 and 1/4. Can we represent a quarter of a student? No, we can't. So key 3 also doesn't work. So the only one who works here for us is actually key 2. Okay, hopefully that makes sense. So how I would go about this question is just have a look at which numbers we're being offered. And we know that 24 and 18 are going to give us some nice rounded numbers, and we aren't actually going to be able to check all of the fractions. So with Wednesday being 27, we can actually check whether these fractions work for us. Okay. Question 13. Jessica has the following tokens numbered from 1 to 9, and she places them all into a bag. So she takes out 2 tokens randomly from the bag. Which of the following statements is going to be correct? The total cannot be 18 or greater. So what's the highest total we can actually get? The highest total is 9 plus 8, right? Which is 17. So the total cannot be 18 or greater is correct. We can't get 18 or bigger than that. And then question number 2 says the highest possible product is 81. Remember, the highest possible product would be between the biggest numbers, right? And the 2 biggest numbers actually just give us the highest possible product of 72. So statement 2 is not correct. And number 3 says the smallest possible product here is 2. So what are the 2 smallest numbers here to give us the smallest possible product? It would be 1 times 2, right? Which is correct. So as we can see here, only statement 1 and 3 really satisfy our answer. So the answer is D. Okay, cool. Question 14. So the diagram shows a square inside a rectangle. The area shaded is 118 squared centimeters. So remember the shaded area, how we get that is from the big square minus the little square, right? the little part that we've cut out. So to work out the area of the big square, sorry, not the big square, it's actually a rectangle, is 11 times 13. Let's call it the big shape instead. 11 by 13 minus the little square. That one we know is a square, okay? And we're told that the shaded area is 118 squared centimeters. So what you guys can do here is you can do 11 times 13, for example, and then subtract it, 118 from it, for example. You can think about it as if you know your 12 time tables or your 11 times tables pretty well, we should know that 11 times 12 is 132. So you just need to add another one on top of that, all right? So we can do that one pretty quickly, or you can just write it out fully. That's up to you as well. And if we just do that one, we should get 143. So we know that 118 centimeters equals to 143 minus the little square. So 143 minus what gives us 118? It is minus 25, right? And we know that 25 just means that it would be a 5 by 5 square to give us a area of 25 squared centimeters. So the answer has to be A in this case. Okay. And the reason for that is because it needs to be 5 by 5. Cool. Question 15. Let me zoom out a little bit. So a deep fryer is leaking at a constant rate. So Patricia places a bucket underneath the fryer to catch the oil. Before placing the bucket underneath the fryer, she weighed it on a set of digital scales. So we know that this is actually really similar to the question we did earlier, right? So the bucket, we know it weighs 0.3 kilograms by itself. And we know that after 6 hours of leaking, essentially with a bucket full of oil, we have 1.5 kilograms. So we know bucket plus 6 hours of leaking equals to 1.5 kilograms, right? And as we did before, remember how I substituted the bowl, for example, or the bucket. So we can do the same thing here. We can substitute its weight and we can write it out like that. So now we can remove things from both sides, right? We can subtract 0.3 kilograms from both sides to get that 6 hours of leaking. After 6 hours of leaking, this thing still weighs 1.2 kilograms, right? So what we can do from here is we can work out what 1 hour of leaking would be. If 6 hours is 1.2 kilograms, 1 hour must be 1.2 divided by 6, which is 0.2 kilograms. Okay. And it says if 1 liter of fryer oil weighs 800 grams, how much oil is leaking every hour? So we know 1 liter is going to be 800 grams, right? And that means that we also know that 200 grams would be, we divide both sides by 4 to give us 250 milliliters. Why did I divide it by 4? Remember, 1 hour, right, was 0.2 kilograms, isn't it? Or 200 grams. And we know that the equivalent of 200 grams here would be 250 milliliters of oil. So our answer for question 15 would be C. Okay. Hopefully that makes sense. I'm going to move on to 16. So, question 16. Brendan is thinking of a quadrilateral, which Jen is trying to guess. Brendan gives the following hints about the quadrilateral. There are two sets of parallel lines, and all sides are equal in length. Can we think of a shape? There's actually two shapes that have all sides equal in length. The first one here would be, we can have a square, right? And another one we can have is that also has two sets of parallel lines, would be a rhombus, right? So it's either a square or a rhombus. We can't have a rectangle or a kite or a trapezium because they don't have two sets of parallel lines and the sides aren't equal to each other. Remember, a rhombus is basically just a squashed square. It is a square that we sat on and we squished it a little bit, right? So based on the hints, Jen narrows the quadrilateral to these two possible shapes, right? Which of the following questions should Jen ask to determine what shape it is? You're looking for a property here that would help you to differentiate between a square and a rhombus. So we already know that they have equal sides. We know that they have two sets of parallel lines. But what's the difference between a square and a rhombus? Well, a rhombus is the squished square, meaning that it's not going to have 90-degree angles, right? It's not a right angled shape. So if we ask angle sum of the shape, that's not going to help us because we know any quadrilateral gives us an angle sum of 360. How many vertices? We know both of them are going to have 4. And does the shape have any right angles would definitely help us to differentiate because a rhombus doesn't have any, whereas a square has 4. Are the opposite angles equal? Again, not going to tell us much. And does the shape have any axis of symmetry? Again, not going to tell us much because a rhombus does have symmetry, doesn't it? Okay, diagonal symmetry. So the only one that helps us here to differentiate is, does it have a right angle? Which is C. Okay, question 17. A teacher is dividing his class into 3 different groups of roles. For the class play, he assigns a fifth of the students in costume design. He then assigns 2/3 of the remaining students in cast, and the remaining 12 students are assigned to tech support. So let's have a look at how, we can either guess and check. So there's a few ways we can do this. We can guess and check, and how I recommend guessing and checking is always go from the middle number to know whether you need to go up or you need to go down, for example. Okay. If we guess and check with 45, let's say he assigns a fifth of the students to costumes, right? That would be what? 9 students, and that would be 36 remaining, right? And then he assigns cast, 2/3 of the remaining students would be 24 students. And that would give us what, 12 remaining students, right? And that works out because we know that there are 12 students in tech support. Those are the remaining kids. So C actually works for us, and we guessed and checked it right the first time. Okay. The second way you can think about it is to really do this one with fractions. So we know at the beginning he assigns 1/5 to costume design. If 1/5 have been assigned to costume design, we know that there are 4/5 remaining, right? And he assigns 2/3 of those 4/5 remaining students to the cast. And then we know that he adds the remaining students to tech support to get a whole, right? You can think about it like that, or we can just work out what's going on here first, all right? So we know that this is what, 1/5 plus 8/15, which is the same as 3/15 plus 8/15. And we know that equals to 11/15. So these are the 11/15 students which have been assigned to either costume or cast. So we know that 4 out of 15, aka the remaining students, equals to 12. And what we can do there is we can divide both sides here by 4. That gives us 1/15 equals to 3 students. So if 1/15 of the class equals to 3, then the whole class, aka 15/15, would equal to 3 times 15, which is 45 students. So what I'm showing you guys here is sometimes it's easier to guess and check. Sometimes if you are really quick and you're able to do this, mathematically, go ahead. Okay. So hopefully that one makes sense. Cool. So, question 18 is a visual reasoning question, and it is a little bit complicated because it requires you to have a little bit of a think about where the shapes are going to go. So, it says a cube has a corner that's been sliced off, and which of the following diagrams could show a possible net for creating the new shape? So, let's have a look at each diagram one at a time. If you guys have a look at diagram 1, can we see that this triangle here doesn't actually exist in diagram 1? Whereas if you look at diagram 2 and 3, we can actually see the net of that triangle. This one here isn't going to fill in the shape, is it? It's not big enough. So just by looking at this, we know diagram 1 is not going to work. Okay, that eliminates option B and option D. If we have a look at diagram 3, there's also something really interesting. So if you see here, can you guys all see that the sides that have a little notch cut out of it have to be touching each other, right? Whereas if you guys look at diagram 3 here, can we see that if this was the base of the whole cube, if we fold these shapes up, this one will fold kind of, if that's the base, this one will fold to the side, this one will fold to the other side, right? Do these edges actually end up touching each other? They won't. The only way they could touch each other is if this edge wasn't on this side, but instead it was here. That way, when you fold it up, they would be touching. Okay, so because it's not on the right side, the cut hasn't been made on the right side, this one isn't going to work either. Okay, does that make sense to everyone so far? Hopefully. Um, if we have a look at diagram 2, can you guys see that these two edges are touching each other like we want? We like that. Okay, that's a good start. And let's now check whether this is really going to work. Okay, so let's say that this is the very bottom of the triangle, right? This one here would go, to this one would kind of like fold up this way, right? And then this guy here would fold and touch this side here. This one here would fold and touch this side here, leaving this last little flap here to swing over the top and actually meet up with this side here. Okay, hopefully you can picture that one. So let me repeat that one more time. So this, when you fold this side in, this other side, this side here is going to fold into where I've drawn the arrow. This one here is going to fold into the top there, right? Because this will become the other side and this guy will fold on down. And that means that this guy here will swing over the top. He'll be the top face and that little flap there will touch where we want it to be. Okay, so the answer here is diagram 2 only. Hopefully that makes sense. I know these are hard questions and you do need to have a good think about them sometimes. Okay, I would say how to approach these questions, have a check of what doesn't work first. That would probably be your easier way to do it. Okay, question 19, very classic ratio question. So a company has 3 departments, marketing, finance, and operations. There are twice as many employees in marketing as there are in finance, and the number of employees in operations is 1/3 the number of employees in finance. An employee from the project for the company is randomly selected to lead a project. What is the probability of selecting an employee from the marketing department? So whenever we have ratios, I would always say, please, 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 just write down what you know. So marketing ratio to finance, we're told twice as many employees in marketing than there are in finance. So it's 2:1. And operations ratio to finance, it says the number of employees in operations is 1/3 the number of employees in finance, meaning that there are going to be 3 times as many people in finance compared to operations. As you guys can see here, number of people in operations is exactly 1/3 of the people in finance. All right. Now, whenever you see this, you can hopefully recognize that finance is common to both of these ratios, right? So let's smush everything together. We can't smush everything together straight away because finance is being represented by 2 different numbers, right? So let's make these numbers the same first. So to make these the same, let's turn finance into 3 by multiplying the whole ratio by 3 on both sides. So we get 6:3. And now we can finally smush everything together. It would be 6:3:1. The reason I can do that is because finance is now being represented by the same number. Okay, so boom, we're basically done, right? What is the probability of selecting a marketing employee? Can you guys see the total number of parts here is 10? And the number of parts that are represented by the marketing department is 6, right? So 6 out of 10 we can simplify to 3/5, and that gives us the answer of E for question 19. There we go. Okay, cool. Question 20. The following is a fact sheet given at a national park. It details the height of 3 different historical trees. The height values have been torn off the fact sheet. The average height of Alpha and Nano 1A, Alpha 2 and Nano 1A is 72 meters. Nano 1A and Mat 4 is 52 meters. And the average height of all of them together is 63 meters. So we know how to find average, which is the sum of all the numbers divided by the total number of numbers, right? So total number of items, for example. That's what gives us average, right? So if I can express what they've written here at the moment is for this one, it says A alpha 2 plus nano 1A. If we sum their two like heights together, we need to divide it by 2 to give us 72 meters. The average height of Nano 1A and Mat 4 is 52 meters. And we know the average height of all three of them, Alpha plus Nano plus Mat, divided by 3 this time because there are 3 items that we are putting together, gives us 63 meters. Okay, so what we can do from here is let's just make things a little bit simpler, right? Which is if alpha plus nano divided by 2 gives us 72, then we know that alpha plus nano would just be, without the denominator on the bottom, would be 72 times 2, right? Which is 144. Now, how I did that was I multiplied 2 on both sides of this equation. If you guys think about it, if you do a half times by 2, doesn't that just give us 1? Because we can cross out those denominators like that. Same thing here, we can cross out the denominators like that. But as soon as I multiply something on one side, it's an equal sign, right? To keep it balanced, I also do need to do it to the other. And what that ends up giving us is 144 meters. Now, why is that important? Because if you guys have a look up to this equation here, can you guys see to get rid of my denominator there, what do I need to do? I need to multiply both sides here by 3, right? Whoops, times by 3. So what that gives us is alpha plus nano plus mat gives us 63 times 3, which is 189 meters. Ah, look at that. We have alpha plus nano equals to 144. Can't we just substitute that in now? We know 144 plus mat is going to give us 189 meters, right? That means we know that, mat is going to be something. Now, have I chosen the most efficient way of doing this question? I would say no, because we actually don't care about mat. There's a better way to do this question, which is, have a look here. We want to end up with alpha, right? So basically, we want to know what n and m are together, but we don't want to know what a is, so we can solve for it. Should we use this one up here? No, because this one already gives up what alpha is going to be. So a better way to do this is to multiply this guy. This guy is a better option, isn't he? Okay, so now what we can do is we can substitute n plus m, right? So alpha plus 104 meters is going to give us 189 meters, and A would just be, that's a better way to do it, isn't it? So that would be 85 meters, which is D for this question. So how I would recommend you to do this is obviously be good with your averages, but also know which ones to pick, right? A lot of people do like to pick, they just do things for the sake of it, but please have a think about what do I need? Will this actually help me? And in this case, this first one actually didn't really help us at all. We only needed the second one here. Okay, cool. Question 21. So Justin's watch is always running late by the same interval of time. Consequently, when she thought she was going to be exactly 4 minutes early for class, she was actually 9 minutes late. So if you think you're going to be 4 minutes early, but you're actually 9 minutes late, what does that tell us about the time? It's actually 13 minutes behind, right? And then Justine is trying to catch a train scheduled at 2:09 p.m. It takes her exactly 14 minutes to get to the train platform from her house. She glances at the watch and it shows the following time. The current time it shows on her watch is 1:30, right? Within how many minutes does she need to leave the house in order to make the train? So if it's 2:09 p.m., right? She needs 14 minutes to get there. So she needs to leave her house 14 minutes beforehand. So 2:09 minus 9 minutes would obviously be 2 p.m. And then minus another 5 minutes from that would give us 1:55 p.m., right? But we also know that her watch is exactly 13 minutes behind. So to adjust for her watch, we actually need to leave. If it shows 1:55 p.m. on her watch, she's actually 13 minutes behind that, right? So to adjust for that, we need to leave 13 minutes earlier. So the time we need to leave, according to her watch, would be 1:42 p.m. Now, see how her watch is currently showing 1:30? If we need to leave according to her watch at 1:42 p.m., and then in how many more minutes do we need to leave the house to make the train? It will be 12, which is D for this question. Okay, cool. Question 22. So a stationery store stock has 3 times as many pens as pencils. The total weight of all the pens and pencils is 0.48 kilograms. The pens weigh 0.08 grams each, and the pencils weigh 0.06 grams each. Okay, let's write down a little ratio first, which is pens ratio to pencils. Okay, so it has 3 times as many pens as it has pencils, right? So it would be 3:1, for example. Okay. And that just means that for every, 1 pencil we have, we'll have 3 pens. So let's use P for pencils. If P represents pencils, then what would represent pens? It would be 3P, right? Because we have 3 times as many. And now we can use this for this equation here, right? We know that pens, which is 0.08 grams each, right, times 3p, plus 0.06 times by p for pencil is going to give us a total of 0.48 kilograms, right? We know that 0.08 times 3 is 0.24, and this would be just 0.06p, right? And that just means altogether that would be 0.3p equals to 0.48 kilograms, right? And we can now solve, this for just p itself. So yeah, if we divide both sides, or we can write this down, this might be easier if we write it down into grams first. We divide both sides here by 0.3. And hopefully from doing the, mental maths behind that, sorry, I wrote 4,800. I meant to write 480. There we go. Let's fix that up. Divided by 0.3, you should hopefully get 1,600 grams. And how I know that is because I know 480 divided by 3 is 160. So we need to add another 0 to account for the decimal point. And it says, how many more pens are there than pencils? So we know that means that the pencils are going to be 1,600. And that means the pens is going to be 3p, right? Which would be 4,800. How many more pens do we have compared to pencils? It would be 4,800 minus 1,600, which is 3,200. The answer there is E. Okay. Question 23. So the X route bus is scheduled to run every 2 hours and 30 minutes, right? So let's write that out into 150 minutes. The reason why I'm doing that is because it's going to come in handy later on. The Y route is scheduled to run every 1 hour and 45 minutes, which we know is 105, right? And the first X route bus and Y route bus both start their routes at 6 a.m. and continue until midnight. How many hours are there between 6 a.m. and midnight? Well, there are 18 hours, right? And how I know that is 6 a.m. to midday is 6 hours, midday to midnight is 12. Okay, and we know that 18 hours is going to be how many minutes? It's going to be 18 times 60. How you can do this is do a quick 18 times 6, which is 108, and then add the 0 back in. Why is this all important? Because it's easier to divide minutes than it is to divide like hours and work out things with decimals as well. So that means that the X route, which runs every 150 minutes, would run this many times, right? So 1080 divided by 150, you should hopefully get 7. And the Y route would be 1080 if it comes every 105 minutes. It's going to run exactly. Do we know what it is for 1080 divided by 105? You would get it to run almost about 10 and a bit times, right? It's not going to be perfect, but it's going to be exactly 10 times within that frame because we know that 105 times 10 is 1050 and it's not going to run again in that time, right? So we can pretty confidently say it's just going to run 10 times per day, okay? So it says, what's the difference between the number of times that it runs in 1 week, right? So If we have a look at a week, if it runs 7 times a day, then we know in 1 week it's going to run 49 times. And in 1 week, this one is going to run 70 times, right? So the difference is just 70 minus 49, which in this case is 21. The answer here is B. Hopefully that is okay. And hopefully I'm not going too fast for you. Okay. All right. Question 24. So Jennifer and her husband Steve both have their individual banking accounts as well as the joint banking account that they share. The following table shows information about the banking accounts. However, the balances have been blurred out for privacy. So the net balance of an individual is calculated by summating all the account balances that they have ownership or joint ownership of. The joint account has twice as much money in it compared to Steve's individual account. Okay, so we're looking at Steve. Steve is who's of interest to us right now, right? So we know that for Steve, the joint account ratio to his individual account should have twice as much money in it, right? And we know that net balance here means joint plus individual, right? So what do you see here? Something with a ratio, something with a total. That means we're probably interested in the total number of parts. We know Steve's ratio has a total of 3 parts in it, and that equals to $57,000, right? If 3 parts is 57,000, then 1 part is going to be, hopefully you get it, 19,000, right? Whoops, too many zeros. Okay, so that means that in his individual account, we know that Steve has 19,000. What about the joint account? The joint account has double the amount of parts, right? So 19,000 times 2. Oops. Okay, and that means that Jennifer, right, she has 38,000 plus her individual amount to give us a total of 65,000, right? So we can assume for Jennifer, she would have 65,000 minus 38,000 in there. Okay. And the answer you should get for that is 27,000. Okay. So now your job is to work out what the total balance of all 3 accounts would be, which is 19 plus 38 plus 27. And hopefully from that, you should get $84,000. Hopefully that one is okay for you guys. Okay, it's a very classic ratio question. Alrighty, question 25. Emma runs and organizes a book club meeting for older people to allow them to practice literary skills, engage in social activity, and enjoy reading as a hobby. She runs a group book reading um, every 2 weeks and a group discussion every 3 weeks. She also runs a scheduled author Q&A session every 4 weeks. She holds all 3 events together on the first week of the year. How many times in a year will she run exactly 2 events scheduled together, assuming that there are 52 weeks in a year? Now, this is a bit of a tough question because it requires a lot of, what if she's running this and that, and what if she's running this and that, right? So, how I want you guys to think about this is you can consider it into different cases. So, the first case would be she runs what? Book reading and group discussions, right? And how do we know how many times a year she's going to run that? Well, we know that their LCM is going to be 6, right? So they get run together every 6 weeks. So if she runs it in week 1, she's going to run it again like week 7, week 13, week 19, right? And just keep adding 6 to it, okay? Week 31, week 37, and we know week 42 and week 48, right? Did I miss something? Sorry, this is meant to be 43. There we go. Okay. And number 2, the second one is going to be either, let's say, a book reading plus a Q&A, right? Their LCM here is going to be every 4 weeks, right? So the LCM between 2 and 4, that is. Okay. So if she runs it in week 1, it's going to come again in week 5, week 9, week 13, 17, 21, 25, 29, 33, 37, oh my goodness, 41, 45, and 49. Okay. And the third and final scenario, promise it ends, right, is the only other 2 that we haven't put together just yet, which is discussions and Q&A. Okay. So if we're doing discussions and Q&A, hopefully you guys can see that their LCM here is 12 weeks. So that means that if she runs it in week 1, it'll come again in week 13, week 25, week 37, and the lucky last one would be week 49. That one's nice and easy, right? And now we can just see that there are some things that overlap here. Do we care about week 1? No, because it's already happened, right? But what else here is common? Hopefully you guys can see that 13 keeps coming up, 25 keeps coming up as well, 37 keeps coming up, and 49 keeps coming up. Okay, so there we go. Those are the weeks where we have, one thing running, but not something else. So in total, we have 12 of them, right? 4 for each time. So the answer is B. Okay, hopefully that makes sense. And question 26. Martin is playing with with toy trains identical to one another. Each train carriage comes with two connectors, 1.5 centimeters long in length on either end, which can overlap perfectly with the adjacent carriages to make a longer train. This leaves a 1.5 centimeter gap between each train carriage. So the length of a train is calculated from the front of the first carriage's connector to the end of the last carriage's connector. And it says the Martin joins 4 of the carriages together and finds a total length of the train to be 51.5. So hopefully from this you can see that the train here would look like this. So we would start with one thing, we would have the main part of the carriage, then we would have a connector with another main part, a connector with another main part, and a connector with another main part, right? And a little bit on the end. We know each part of this connector is exactly 1.5 centimeters long. 1.5, 1.5, 1.5, right? Okay, and from this, right, we know that all of this together, aka 4 carriages plus, there are 5 1.5s here, right? So that would be 7.5 centimeters, gives us 51.5 altogether. So 4 carriages here would be 51.5 minus 7.5, and that gives us 44 centimeters. So that means that one carriage, aka just this part here, would be 11 centimeters. So it's asking us what is the length of one entire train carriage, meaning that they want us to just include the connecting parts as well. That would be 11 plus an extra 1.5 plus 1.5, or 3 centimeters, you can think about that, is 14, which is E. Okay, hopefully that makes sense. Question 27. So Elena is shading in a square grid as shown below. She wants to shade extra squares to make a pattern with exactly 4 lines of symmetry. What is the smallest number of extra squares she would need to shade? If you want 4 lines of symmetry across a square, you're probably thinking of vertical symmetry, horizontal symmetry, and the 2 lines of diagonal symmetry. So if we're looking at vertical symmetry, what would she need to shade here? She would need to shade this one up here, this one here, and this one, right? If we're looking at horizontal symmetry, hopefully you guys can see they're already horizontally symmetrical. And if we're looking at diagonal symmetry, let's look at this line first. Do we see what we might need to shade? So if we're looking at this, can we see that we need to shade this one here? Hopefully we can see that. And we'll also need to shade this one here, right? And when you fold these 2 corners down on each other, they are going to overlap in this corner here, but this one here is going to represent this guy, isn't it? And this one here is going to represent, this one. Okay, so that's showing us, and if we just do it across obviously the other diagonal, hopefully you can see that that is also diagonally symmetrical. How you can imagine diagonal symmetry is if you fold the shape across the line, does it match up? So what is the smallest number of extra squares she needs to shade? All you guys need to do now is count, right? 1, 2, 3, 4, 5, 6, 7. So the answer here is E. She needs to shade 7 of them. Okay. Question 28. So Emma owns a flower shop and she makes a large flower arrangement that consists of either red flowers or yellow flowers. And she has 200 flowers altogether. Which of these statements can't be correct? So Emma uses 80 more red flowers than she does with yellow flowers. She used 3 times as many yellow flowers as red flowers, or she used twice as many red flowers as yellow flowers. Okay, let's have a check of whether these work. I think number two is probably the easiest one to prove, which is if she used 150 yellow flowers and 50 red flowers. I think that one is pretty straightforward. And if we have a check of number one, using 80 more red than yellow, you could do that, which is 140 red and 60 yellow. And Emma used twice the number of red flowers compared to yellow flowers. How we can check this is, if we write this in a ratio, it should look like 2:1, right? The total number of parts here is 3, and the total number of flowers here is 200, right? So we can't divide this nicely because 3 doesn't divide nicely by 200. So the one that doesn't work here is 3, but these two both work. So statements 1 and 2 only. Okay, cool. Question 29. Question 29 says, Barry has a piece of 10 by 10 square grid paper. He traces the following hexagon onto a piece of paper. He wants to cut out the same hexagon as many times as possible from this piece of paper. What is the maximum number of hexagons he can cut from the grid paper? Now, I know it is so tempting to just draw this like that, right? It is really, really quite tempting. Whoops. Let me draw that a little bit better. That is really quite tempting. And you guys will notice if we do that, we can actually only fit 3 in each of these rows. And then you would imagine there's 3 there, right? And 3 there. So I guess like you might be thinking, oh, it must be 8 then, right? But this is not actually the most efficient way to do this question. The more efficient way to do it is if we pack these shapes as closely together as we possibly can. So if you guys have a look here, I can actually pack one more hexagon here, can't I? I can pack one like that, right? And then similarly, I can pack another one like the other previous hexagon, which is like this, right? Hopefully you guys can see that. And then again, one more just on this side here. Okay, so we can actually fit a maximum of 4 in each row. And we have, again, like, 3 rows of that, right? So we can fit those across these as well. Okay, so what ends up happening is the maximum of hexagons we can actually cut from this would be 4 like that, 4 like that, and we can fit in some couple more. Okay, so hopefully from that you understand that we can pick 12. And I know you might be thinking that you actually need a row of 1, 2, 3, 4. But remember that obviously where I've drawn my circles isn't a perfect representation, right? Because we can fit them in like that, if that makes sense. And we can end up with 3 rows of that because again, we can fit another one down there, if that shows you guys what I mean. Okay, so that's how we can do that. So that's why we can do a 4 by 3 row, which is 12. Okay, question 30. Alice and Benjamin are playing a game where they exchange cards. They start by holding an equal number of cards in their hands. Each round, both players will take a turn. On each player's turn, they roll a regular six-sided die, and the number rolled is the amount of cards that must be given to the other player. Alice takes the first turn. After 3 rounds, Alice has a total of 35 cards. What is the maximum number of cards that they could have started with? So we know that they give out however many cards they roll, right, on the die. So what's the maximum number of cards that Alice can give away? We want her to give away as many as possible, right? Or receive as many as possible. And, we want to find out the maximum, sorry, we want to find the maximum that she could have started with, right? So we want her to give out as many as she can. So across the 3 rounds that we do, we want her to give out 6 cards every single time because that's the maximum number of cards she can give out. So that means that across the 3 rounds, she gives away 18 cards, right? And what is the minimum number of cards that she can receive? So the minimum number of cards that Benjamin has to give her is going to be for the 3 rounds, he rolls a 1 every single time and he only gives her 1 card. So that would be 3 cards in total. And so that means that the difference between this is 15 cards, right? Meaning that there's a total difference between her starting deck and her ending deck by 15 cards. Okay. And that just means that at the beginning, she would have had 35 plus that difference, which gives us 50 cards. And our answer there is B. Hopefully that one makes sense. So what I'm doing here is to work out, to maximize the number of cards she had at the beginning. I want her to give away as many cards as possible, right? And to get as few as possible. And that means the maximum number of cards she can completely give away is 18. The minimum number that she can receive is 3, meaning that there's a difference between how much she started with and how much she ended with of 15 cards. So in total, she'll have 50. Okay. Question 31. So, a taxi driver is driving in the city where all the roads are straight and point either north, east, or northwest. At each intersection, he can either turn right, turn left, go forward, or make a U-turn. He begins traveling in a southwest direction. All right, let's draw that first. So, north is this way, southwest would be in this direction, right? That's his first step. That's where he's going at the beginning. Can you guys see these first 2 steps here actually cancel each other out? So we don't have to do that. If you turn right and then you turn left, you're going to be in the same direction, aren't you? So the first step here is we're going to be doing his left turn, right? So if he's doing his left turn, what direction will he be then facing? If he's first going this way, his left turn is going to make him face southeast, right? Then he goes straight and straight. Then he does a U-turn. So a U-turn would mean that would send him to a northwest direction. And then he does a right turn, which would then send him to a northeast direction. So our final answer there is A for question 31. Okay. And question 32. So the following shape has an 8-axis of symmetry and a perimeter of 64 centimeters. Maria arranges 2 of the same shapes together to form a new shape shaded below. What is the perimeter of this new shape? So as we can see, this new shape is made up of 4 sides from this original star, right? So let's have a look at this. This star here has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 sides. And we know those 16 sides added all together gives us a perimeter of 64 centimeters, meaning that one side, if you divide both sides here by 16, should give us 4 centimeters as the side length of the star. And we know this shaded shape equals to 4 side lengths, right? Which would be 16 centimeters because we know one side length was 4. So that gives us the answer of A for question 32. Okay. Question 33. Daniel writes down the number 23. He then reverses the 2 digits and subtracts 7. He finds that this makes a positive number that is a multiple of 5. So hopefully you guys can see here, he reverses the digits, right? So he turns 23 into 32. Then he subtracts 7 to give him 25, and that's the multiple of 5, right? How many 2-digit numbers, including 23, also follow this pattern? So hopefully you guys understand that anything that is a multiple of 5 has to end in either a 0 multiple, let me write that a little better. Multiple of 5 has to end in either a 0 or a 5, right? And to get that after we subtract 7 from it, we need a number that ends in either a 7 or a 2. Yeah, so if we subtract 7, we would only end up with something that ends with a 0 or a 5 if it ends in a 7 or a 2. But remember, we only end with a 7 or a 2 after we flip the number, right? Meaning that the first digit has to be either a 2 or a 7. Hopefully that makes sense. So that means that the first digit is a 2 or a 7. So yeah, hopefully that one makes sense. Okay, so if we look from the 20s and we look from the 70s, every single one of these digits is going to give us 1, but except for except for 70 and 20. These two guys are our exception, right? Because if we reverse the digits and then we subtract 7 from them, obviously it would be like 2 and 7, right? And if we subtract 7 from them, they're not multiples of 5. So the only ones that work are there are only 18 digits that do the trick, okay? Not 20. And yeah, hopefully that one makes sense. It's a little bit complicated, but if you think about it, any multiple of 5 needs to end in 0 or 5. And if to subtract 7 from it to still end up with something that would end in 0 or 5, we would need something that ends in 7 or 2. But that was only after we flip the number, right? Meaning that we need something either in the 20s or the 70s. And we know there are 10 digits belonging to each of those tens. And so except for 20 and 70, they all work. So there's 18 of them. Okay. Question 34. Harrison constructs a large solid cube from smaller unit cubes. He then paints the entirety of exactly 3 sides of the larger cube with blue paint. Upon deconstructing, what are the possible amounts of smaller cubes which have exactly 2 sides that have been painted blue? So this question has 2 different scenarios, right? As you guys can probably tell because there are 2 answers in every option. I think one really good way to go about it is you can think about it when all the sides are stuck together. So, for example, if he painted this side blue, and this side blue, it would be different to if he painted the top, the side, and the bottom blue. Okay, so let's say he paints adjacent sides, right? So when all sides are next to each other, hopefully you guys can see the ones with 2 sides painted blue are going to be this one, right? This one, this one, this one. It's not going to be this one because this one will have all 3 sides painted blue. You'll also see that this one works, this one works, this one works, this one works, this one, this one, this one, and this one will all work, right? So that gives us what? 4 cubes for every corner or every edge. So if we paint adjacent sides, we'll end up with 12 cubes that have exactly 2 faces painted. If we paint opposite sides, right? Opposite sides. We won't run into the issue of the corner cube having 3 faces painted. So let me show you what that might look like. We'll have this face painted, this face painted, and that bottom face painted, right? So you guys can see that you would have 1, 2, 3, 4, 5 here, and also 1, 2, 3, 4, 5 there. So that would give us a total of 10 cubes. So that's your answer for question 34. And lucky last, question 35. The following spinners have equal odds of landing on any of the 4 numbers on the spinner. Andrea spins each spinner once and must use both numbers she lands on to form a 2-digit number by using the numbers as digits. What are the chances she spins 2 numbers that can form a number that is divisible by 3? So first of all, let's have a look at how many options do we have in terms of, how many combinations of numbers can we make? So this is very similar to if I have 4 t-shirts and I have 4 skirts. Sorry, that's my dog. 4 t-shirts and 4 shorts. How many combinations of outfits can we have, right? It would be the same thing, which is we have 16 possible combinations. Okay, and that would be our denominator because we're looking at probability, right? And it says that we can form a number divisible by 3. So let's have a look at what kind of outcomes that would give the sum of a number that is divisible by 3 if we know our divisibility rules. So one of the options is a 9 and a 3. Another option here would be like, for example, 2 and 7, right? Another option here would be 4 and 5. Another option here would be 4 and 8. And one more would be 6 and 3, right? So are there any other options that we can think of? I don't think so. And that gives us a total combination of 5 of them, right? 5 out of 16 possible combinations together will give us an answer. Okay, and that would be D. That is question 35 and the final question from this paper. So I think there will be some questions coming through in terms of what you want me to go through again. So I will wait for those to come through. Um, I'll just wait for your questions to come through. They haven't been sent to me just yet. Question 19. The answer for question 19 was E. Would you like me to go through that one again or no? Question 28. Okay, question 28. So question 28 is that which isn't okay. So for question 28, Emma owns this flower shop. She uses 200 flowers altogether, right? We're checking whether each one of these options will work. So if we have a look at question number two is probably the easiest one to get. If there are three times as many yellow flowers as there are red, we can assume that the ratio of yellow to red is 3 to 1, right? So we know that there are 4 parts in total, and that represents 200. And because it's divisible, 4 is divisible by, sorry, 200 is divisible by 4. We know that 1 part equals to 50. And we can see that this relationship works. We can have 150 yellow flowers and 50 red flowers, right? So that's why number two works. Number one says Emma used 80 more red flowers than yellow flowers. So this one also works because we can do 140 red flowers and 60 yellow flowers, which means we use 80 more red. And number three doesn't work because if we use twice as many red and yellow, that means that ratio is 2 to 1, right? That would be a similar thing. We have 3 parts equals to 200, but 200 is not divisible by 3, which means that we're going to get a fraction or a decimal, and that means we can't obviously divide the number of flowers into decimals. So that means that number 3 doesn't work. So our answer is statements 1 and 2 only. Hopefully that makes sense. Okay. Question 19. So with question 19, so what we're looking at is marketing, finance, and operations, right? It's a very classic ratios question. So let's write down the ratio for marketing ratio to finance first, which is twice as many employees in marketing than there are in finance. And the number of people in operations is a third of the number of people in finance, right? Meaning that for every one person that's in operations, we should have 3 people who are in finance. That gives us that ratio that we're looking for, or the fraction we're looking for, which is a third of the people in operations are in finance. Okay, so what we notice from here is that finance is present in both of these ratios. They represent the same number of people, but they're being different numbers are being used in this ratio. So the way to make these ratios work together is by representing finance by the same number, aka 3. And to do that, we need to multiply both sides of the ratio here, right? So we end up getting 6 ratio to 3. Now we can actually put everything together, which is 6 ratio to 3 ratio to 1. And why that works is because we're looking for the probability of selecting an employee from the marketing department. We know that the total number of parts here is 10, 6 plus 3 plus 1. And the probability of selecting people would be 6 out of 10 parts of this ratio, aka we can simplify to 3 over 5. So the answer to question 19 is E for this reason. Any other questions? Are there any other questions? If not, I'll say thank you so much for attending. And hopefully you got something out of that, whether that is being able to work out something a little bit quicker, working out a different way to guess and check from the middle, for example. Yeah, and just some faster ways to do questions. I hope you guys have, you know, taken something from this, and all the best for your exams if you have them in, a couple weeks' time. Question 21. Okay. Okay, let's do question 21. So let me rub all this out. With question 21, Justine's watch is running late, right? And when she thought she was 4 minutes early, she was actually 9 minutes late, right? So what we can tell there is there's a 13-minute time difference, right? She thought she was 4 minutes early, but in fact she was 9 minutes late. So her watch is 13 minutes late. Okay. And we know she's trying to catch this train, which is at 2:09 p.m., right? And we know it takes her 14 minutes to get there. So she needs to leave her house 14 minutes beforehand, aka that's going to be 1:55 p.m., right? 2:09 minus 9 minutes is 2 o'clock, and then 2 o'clock minus another 5 minutes is 1:55. And that means that normally, if her watch was working normally, we would leave at 1:55. But again, her watch isn't, right? It's 13 minutes late. So according to her watch, we actually need to leave 13 minutes before what her watch actually says, which means we need to leave at 1:42 according to her broken watch's time. And her broken watch at the moment actually reads 1:30 p.m., right? So that means that we need to leave in 12 minutes time in order to make this train, okay? So that's why the answer is C, because her watch currently reads 1:30 p.m. On her watch's broken time, we want to leave at 1:42, right? Are we okay with that? Hopefully that makes sense. 23. Okay. Question 23. Okay, so with question 23, we know that the buses both start at 6 a.m. and continue until midnight. So we know that they run for 18 hours in total, right? And we know that 2.5 hours and 1 3/4 of an hour aren't really exactly easy times to work with. So let's convert everything into minutes just to make our life a little easier. So 2 hours and 30 minutes would be 150 minutes altogether. And 1 hour and 45 minutes would be 60 plus 45, which is 105 minutes, right? And we know that 18 hours is going to be 18 times 60. And we know that 18 times 6 is 108, right? So add the zero back in. We know that 18 hours is the equivalent of 1,080 minutes. And so what we can do now is we can test each bus, right? How frequently does each bus run during that day? Um, if it runs every 150 minutes, for example, right? So we can do 180 divided by 150, and we get about 7, right? It's actually 7.2, but we're not going to get enough time to run an eighth bus, right? So we can say confidently that the it runs 7 times a day. And the Y one is the same thing. We do 1080 divided by 105, and we get about 10. It's actually just over 10. It's like 10 point something, right? But again, we're not going to get time to run an 11th bus, so we can just say it runs 10 times a day, right? So that means that's 7 times per day. This is 10 times per day. And we're asking for what is the difference in, how much these buses run within a week, right? So if it's 7 times a day, we can say that's going to be 49 times per week. This will be 70 times per week. And the difference between these two would be that Y runs 21 more times than X does, right? So that's the difference there. Okay, cool. Yes. This is the mathematical reasoning challenge. So these are the kinds of questions you would expect to see in the maths section of your test. Keep in mind that there are 4 sections. So there's also thinking skills, and there's also reading, and there's also writing. This is only one of the 4 tests. So I would say these are kind of the level of questions you might see, maybe even slightly harder. But if it is slightly harder, that's a good thing for you because then you're more prepared. Um, but yeah, these are the kind of questions you should expect. Bit of mix of problem solving and some of your basic math skills as well. Yeah. Okay. Thank you guys so much for attending. I really hope you got something out of it. Thank you for spending your Saturday evening here with me. And all the best to you guys for your test or any future tests you might be going to. Thank you, everyone, and good night.